Hi, everybody. Thank you for coming right after lunch at nap time. I do appreciate that. I know it's not easy, but I'll try to keep this engaging. So I want to start with this slide. I was just telling a friend, as I was building this deck, I had to change this slide like 5 times because new things come up all the time. This is the CISA warning from 4 days ago. About the active exploitation of a GitLab password reset vulnerability. How many people here heard about the GitLab password vulnerability? Less than half. Okay. This has been around for 4 months. It's already, it's old news. It was actually my first slide in my first draft, and then it swiped out because new things came. But it's now still being exploited in the wild. And so that's where we start the essence of this talk. A little bit about myself before I dive into that, because I think myself describes this talk really well. So I've been doing AppSec most of my life. I'm really excited about this talk because it brings my old world, AppSec, which I've been doing most of my life, and my new world, which is incident response in the cloud. And so I've done AppSec for many years. I've built a company. I was part of Synopsys, Pentest, Builder, Breaker, Defender, everything. And after doing that for 20 years, I decided that it's time to go to the response side because, well, we're kind of failing on preventing breaches all the time, and I have another talk on that as well. But I started looking at IR, and one of the really interesting things that happens when you do IR is that you discover what's real, right? Well, vendors and everybody, practitioners in the prevention side, we talk about risk. We want to prevent this risk and this risk and this risk. And we're often focused on risk based on what we think is the risk or what we perceive as the risk or what we can, as a pen tester, achieve as a risk. But as an IR, I see what hackers are really, really using in the world. Because there are things that maybe you can do as a hacker, but attackers are not very interested in them. And so this talk talks about what we see as real threats in the AppSec world, what we see right now going out in the wild, and helping you focus your energy and your expertise on preventing those things. So I think the most interesting thing is that attackers are targeting dev infrastructure, so developer tools, open source libraries, everything around the infrastructure, especially in the cloud, and we'll talk about that. Much more than they're targeting custom code. And I can tell you in 4.5 years that Minigun, my company, exists, we do IR, we had only 3 incidents that were a result of an abuse of custom code, of a vulnerability in custom code. We had tons of incidents that were abused of a hacked GitHub account or a misconfiguration or open source library or anything of that sort. And the reason is because, well, hackers are lazy, and hackers is a business, right? It's not like, oh, I'm a cool pen tester. I found the nicest, coolest exploit in the world. No, it's a business. And in business, you want to invest minimum effort and get maximum outcome, right? Like any business, ROI. And attacking infrastructure is scalable. I do it once. Maybe it's a little harder to do it, but I do it once, and I can replicate it across thousands of organizations, ending up with tons of ransom demands that I can do. Whereas custom code, I find a vulnerability. It's one company, okay. Maybe it's great, but it's not as common. So I want to talk to you about this, and I'll start with a little bit of the news so you see I'm not making all of this up, right? So you probably heard about Midnight Blizzard. It's a big attack on Microsoft, probably Chinese related. And immediately one of the things that pop up is they went after the Microsoft source code. Why? Because that's a developer infrastructure. Microsoft is an infrastructure for everybody, right? GitLab, we just talked about it. So somebody found a vulnerability in GitLab that lets you reset passwords with one click, meaning you send somebody, like a cross-site scripting, right? Send you a link, you click it, it resets your password. Now the attacker can go in. It's a really, really bad vulnerability, and it's been 4 months since it's out, 3.5 months since it's out, sorry, since it's been discovered, probably been out longer, and we still see it in the wild, and it's being actively exploited because when I get access to GitLab, I get access to your code. When I get access to your code, I get access to your secrets, and we'll see example of that. JetBrains, again, mass exploitation. We've had Circle CI last year. That was a really, really big one. So Circle CI is your CI/CD platform, pushes everything to production, has permissions to all your production systems if you use it for proper CI/CD. So I can take over your entire production with that, right? And again, I picked 5. I had like 500 of those when I was doing the deck. Mercedes source code exposed by a leaked GitHub token, right? So some of these target the vendors themselves, right? Finding a vulnerability in GitHub or GitLab, but some of them just go after a specific account. So I want to talk something about incident response in general, because most people in AppSec don't really experience incident response in their life. So one of the things, this is a really crazy statistics to anybody who hasn't experienced a lot of IR in their lives. Most incidents, I'm talking about big incidents, right? Not, oh, somebody clicked a link, but we have a $5 million ransomware. Most incidents are not discovered by the company who was breached. So only 1/3 is discovered by the company who was breached. 2/3 are discovered either through you got a ransom note, or one of your customers alerted you because they discovered something, or the FBI or other law enforcement alerted you, or the media. That's generally how people discover. And so that is because detection is a very hard thing to do, and again, if you do detection well, then you're not going to get breached. So a lot of the breaches manage to get through your prevention and detection systems, right? And that is true even more so in code and developer infrastructure, because for many years, the core of our detection and response technologies were for the core of our IT, right? Our firewalls, our identity, not so much on GitHub. And I don't know how many of you actually send your GitHub logs to a SIEM in your organization and monitor them. So let's talk a little bit about how do we attack DevTools. So DevTools, and again, there's a lot of DevTools, but I'm going to focus mostly on cloud because everybody's moving to cloud-based tools, right? SaaS, GitHub as SaaS, GitLab as SaaS. And then they're just like any other cloud environment. And so what we see is that the 2 most prevalent initial access vectors now in the cloud are identity. And it's really interesting, right? So for many years, we had firewalls and VPNs and all that stuff protecting our perimeter. And then we moved to the cloud, and we had all these different resources, and people would lose passwords. So we would tell everybody, well, you should get single sign-on, right? We all now have single sign-on, Okta, Azure AD, whatever. And then now this is our single point of failure, right? So if I breach an Okta account, I can get to all the things that it's connected to. And so that's what's happening. We do a lot of IR. 50% of all incidents we see start with a compromised account, phishing and so on. So you might tell me, wait, we have MFA. You can't compromise our accounts, right? So MFA is no longer useful. I'm not saying it's not useful, right? You have to have MFA, but it's not enough because there are ways to trick MFA. I don't want to go too deep into that, but there are basically 2 dominant technology. The more popular one is called MFA push fatigue, and it's basically working well with all the providers that let you approve your MFA, right? Oh, you logged in on this device, click OK. So what the attackers do, they do a phishing, they grab your credentials, then they start logging in. You get a push, you say no. You get a push, you say no. Eventually you say yes. Maybe not security people, but the rest of the world. We had incidents where 3-4 times is what you need for a user to push for yes, and then another 3-4 times for them to push it again so the attacker can create a new MFA device. And the other technique, a little bit more complicated, but works with the new techniques that have you type the code and the one-time passwords as well. It's called adversary in the middle. The attacker is basically building a proxy. I don't want to get too much into details. You can read about it in Microsoft adversary in the middle. But basically, they're building a proxy. You log in. You then give your one-time password or your push code, and it goes all the way, and they have a live session, and now they do what they want. This is happening all the time on the internet now, all the time. And it's very hard to prevent it. And so once they get single sign-on, well, you know, I got Okta, single sign-on portal. Oh, and all your apps are mine. Because that's it. There's no additional security. Sometimes people put them, but most of the time, not. So I want to talk of a real-world example, Sisense. Anybody here heard about the Sisense breach? Very few people. OK, so Sisense, if you don't know them, they are, well, no longer a startup. They're a big unicorn. They do data analytics. They work with over 1,000 customers. Most of them are big companies. So a lot of Fortune 500s are their customers. And they basically siphon a lot of business data and do data analytics on it. And they got breached. We'll talk about that breach in a second. And they didn't know about it. And through their breach, other customers were impacted. And this got all the way up to CISA, right? And CISA issued this alert, which is pretty severe alert. And they say, you know, there is a breach. You should rotate all your secrets that you ever gave to Sisense, and you should investigate to see what they did. So let's look at what happened at Sisense before we look at what happened at their customers, right? So what happened at Sisense, again, they're not my customer. I didn't do the investigation. It's all based on internet information. But what happened at Sisense, our friendly hacker found a way to compromise a GitLab account. I don't know what was the way. Is it MFA circumvention? Did they found some other way? But they circumvented, they compromised the GitLab account. That GitLab account had access to their code. Their code had secrets. I know none of you have secrets in your code, right? None of you have secrets in your code. But all of you have secrets in your code, right? Every IR where code is compromised, we come in, we ask, do you have secrets in your code? They always say no. They always have the secrets, right? And so they got the secret. It led them to a bunch of S3 buckets, which incidentally held all Sisense customer data, terabytes, or maybe not all, but a lot of Sisense customer data, terabytes of data. But what's really interesting, that it held millions of secrets. So they were holding the secrets of their customers inside the bucket and not in a key management system, for instance, which is also what they should be doing with their code, right? And that included access keys, password, SSL certificates, the whole shebang, right? Everything. And then the attacker got that and started going after the customers. And so imagine yourself right now, you're a Sisense customer, right? You get this alert, and you don't even know what to do, right? You're not going to see any malicious activity, because once they got a valid secret, they can use the valid secret. It's a valid connection, right? And so CISA said, well, reset credentials. OK, assuming you know which things you gave to Sisense. And then investigate, which means you now have to track all the activity, whole different challenge we're not going to get into right now. So, you know, we tried to give some hints to people on how to identify Sisense accounts. Because now here's the thing. You're going to have the people who work with Sisense. It's some business unit. It's not your corporate IT, right? They know maybe which accounts you have, but SecOps needs to respond now. So, you know, there are hints. There are IPs that Sisense normally uses, and there are names, Sisense and Periscope. That's the names they usually use for their accounts. But that's optional. You can give other names. So, you know, ideally, go check your configuration. And then you want to start looking at what are they doing with, like, OK, I have the Periscope user. What did that user do? Did they just do what normally they did in the last few months? Or do I suddenly see spikes of things that are weird? a lot of access denied. Usually that's a good indicator of an attacker trying to do things. Of course, a lot of discovery. So if you see things like list buckets and get caller identity and things that are discovery in nature in masses, you'd be suspicious. And then also, there are the little hints that help, because a lot of this is automated. So the attackers automate that, right? They find secrets, they automate doing them. So there are tools like Trufflehog, Curl, Bodo that are commonly used by attackers to test the credentials if they're actually working. So seeing them can help. So again, we're not getting deep into investigation, but just get a sense that when this happens, it's challenging. And unfortunately, it's not the first time. It's also not going to be the last time. These vendors, all our third-party providers, are whether they're development infrastructure or people we interact with, are continuously getting breached. And a lot of those are the developer. Again, CircleCI last year, they, again, told everybody, immediately rotate all the secrets that you use with CircleCI, which generally all your secrets probably, right? And what's really amazing is that for us as the IR industry, we hear about that a lot, but the developers don't even hear those news most of the time, because you're building, you're in a different world, you're not dealing with the influx of day-to-day alerts. There's a big influx of those. I want to show you another way where your GitHub can be compromised. And this is, I don't know, every other month we get an incident like this. And this is, I accidentally made my code public. How does that happen? I accidentally changed my code permissions to public, or I accidentally pushed private code into a public repo, or any one of those things. So anybody knows how long after you make a secret in a code public in GitHub, how long does it take for it to be discovered? Immediately, yes. It's about between single-digit seconds to 20, 30 seconds, depending on where in the scanning cycle you are. So there are tools that all they do is run through GitHub, scan for code, and look for secrets. And if you accidentally push something there, it's there. So this is an incident we had. Again, developer accidentally merges his company Git repo into his personal repo. That's also because GitHub makes you put your corporate accounts combined with your personal accounts, right? Which is, we can have another discussion on that. So they merged it. 2 AWS keys got exposed. The threat actor immediately finds those. And one of those keys is used for initial reconnaissance. Again, you can see immediately after, it took them a few minutes to remove that, but it's already gone. And you can see immediately in the logs the Trufflehog attempt to check whether the key works. And then we got, I know, in a few minutes, all these things, right? Tons of get caller ID, get caller identity, a lot of stuff that was denied. Luckily for them, it wasn't a very sensitive access key, and the attackers just did the discovery, and they were able to block it before something bad happens. But again, at this point, you don't even know. And if you don't have the right way to investigate, then you're going to be challenged in figuring out what's going on, right? So these things are happening daily. I mean, we see them every once in a while, but we don't get all the IRs in the world, obviously. These things are happening daily, all the time, every day. And they're much more prominent than anything else we see. I want to move to supply chain and software implants. And again, this is a big topic. I'll go through a couple of examples. This materialized in the middle of me making this presentation, and I couldn't let it go. So how many people here have heard about the XZUtils? Good. We have almost a third of the crowd. So XZUtils is an open source library in Linux that was compromised and almost made it to be one of the best nation-state attack tools in the world, only it got accidentally discovered. So before I go into that, I want to talk something about open source. I remember 20 years ago, or I don't know, 25 years ago, when open source started picking and I started my AppSec career. Everybody was saying, oh, open source is great. It's more secure than closed source because if somebody puts a vulnerability in there, everybody can find it. Everybody can look for it and find it. And the only problem with that story is the can word, because theoretically, everybody can look for it, but I assume a lot of you are AppSec people. You know that looking for vulnerabilities in code is a really, really hard job. And in open source, nobody owns the accountability to do that. And so vulnerabilities in open source just exist forever. And so I honestly think closed source is often more secure. But this is a really, really amazing story, because this is a story of a 3-year project to take over a Linux open source and put a remote access vulnerability in it, which we don't know who's behind it, but normally 3 years projects are a nation, right? And what they did is they basically took over an open source project, I'll show you the timeline in a minute, to a point where they're pushing a remote access vulnerability which can be exploited. And the only reason this failed, and we're having this discussion now, instead of all Linuxes in the world being compromised by this government, is that they did a poor job at writing it. It created a performance issue, and somebody noticed the performance issue. It's not that somebody reviewed the code and found it. No, somebody had a performance issue, so they reviewed the code and found it. So this is a timeline. I'm not really going to read through all of it. You can take it later from my deck. But basically, in 2021, they registered a new user in GitHub, Gia10, started doing things, pushing some commits, building credibility within the open source community. Part of it in the XZUtils package, part of it is other packages, right? Because you get scores in the community. And then they created a bunch of other users, and they went after this part that wasn't very maintained and started sending emails on, oh, we need another maintainer for this, we need another approver for this because it's not being maintained well enough. It's like, and again, this is going on for months and years. And then they took over, or not took over, but started taking over another library, which is a library that does fuzz testing for this library, because they knew that once they introduced the vulnerability, it will be caught. So they took over the fuzz testing library, changed it so it will stop finding that vulnerability until they finally, in 2024, pushed the actual remote access vulnerability to XZUtils. And it made its way to Debian. It's made its way to a bunch of Linux distributions, not the stable ones, only some of the early adopter ones, and then it got discovered. It's mind-blowing to think how well orchestrated it was, and what's more mind-blowing to think, how many like this I can't stand here and tell you about today, right? So this is a really, really big challenge. And again, this is a really amazing story. But we have tons of stories like this that are small and daily and are happening all the time. There is now it's almost at the level of a denial of service attack of malicious repositories being pushed to GitHub. Thousands by the day, which GitHub has to work with. And a lot of them will put a name that's very similar to another open source library. So you search for it, you take the wrong library. We see tons of those. And I want to tell you a story about one of these, because a good example always does well. This is great research, by the way, from Checkmarx. They discovered this. I assume everybody knows them. And in this place, they faked a user that is Dependabot. So Dependabot is a feature in GitHub that will automatically bring dependent libraries when they're updated or when you need them. And you see them in your history as Dependabot checked in so-and-so because you need to update library. So when people see Dependabot check-ins, they're not worried, right? So they managed to fabricate a Dependabot bot user, and then started injecting malicious code that into various repositories. And that code would then steal your GitHub access token. So if you would use a library that the Dependabot got into, and you run their code, that code will steal your token to GitHub, and then they took over your GitHub account, right? Very sophisticated. So it looks something like this. You see, Dependabot committed a fix. Okay, that's an old screenshot. I took the screenshot 2 weeks ago when preparing the slide, but then it was timely, of course. You look at that, it makes all sense, and then there is JavaScript code injected there that will go to your browser when you run this code that looks for input type password and steal it, and also look for other access tokens, right? So very nifty little way to steal things. And again, if you look, by the way, Checkmarx Blogs has tons of examples like this, other places as well. You just look for malicious GitHub repo on Google, you can find a world of discoveries. So going back a little bit to IR, one of the most interesting reads, in my mind, in IR, is a report that IBM releases every year. It's called the Cost of Data Breach Report. They've been releasing it, I think, for 18 years now. They have a big IR practice, and every year they bring really, really interesting statistics, right? The 33% I mentioned before, that's part of their statistics. They talk a lot about the time it takes to detect and respond to breaches. By the way, the number for a very long time, the average number is about 200 days to discover a breach and another 70 days to respond to it in average, which is horrible, but that's a different story. Last year, so this is the 2023 survey, they added a piece on software supply chain attacks. And they said 12% out of all the breaches they saw started with a software supply chain attack. 12% is a lot. It's not 50%, but it's a lot, right? So this is becoming a real big problem. I'm sure next year this number will be higher. Usually when IBM introduces a new statistics in the report, it means it's rising, because otherwise they wouldn't put it in. And what they also shown is that software supply chains are harder to take longer to detect and longer to respond to than the average. And so it means that this is becoming a real, real big problem. And by the way, longer also means more expensive. There's a completely one-to-one relationship between the length of identifying and responding to a breach to how impactful in dollar amount it is on your organization. I want to show you one last type of third-party attack, which is a marketplace attack. So, we talked about open source, we talked about attacking the infrastructure itself, but there's now also a marketplace. Marketplace is a wonderful place where you can buy all those wonderful apps that you don't know who wrote and do great things for your code, right? And so GitHub has a very active marketplace. Anybody can put stuff in there. You give it permission to your code, which is great, right? And so we got an IR a while ago. We had a call from a customer. GitHub emailed us that a vendor of an app we use got breached. That's the essence of the email. No additional information. Did they access it? No. Just, have fun. So they called us. We started investigating. And so what we discovered is that in November, last year, one of their developers installed the Marketplace app. It was a static analysis app for security. Great, right? Then, in April, that vendor was breached. Now, you may want to ask what happened since November to April. Did they use it every day and get a lot of value out of this static analysis app for security? No. They tried it once, they thought it wasn't good, and they left the permissions there because that's what people do. And so in April, the vendor was phished. In May, so a month and a half after that vendor was breached, They use the credentials that this vendor has, its OAuth credentials. They use them to access our customer's repo. Now, this is great. So if you've ever worked with apps in GitHub, they use what's called OAuth to authenticate, which means they have the credentials, or they appear as if it's the user. So if you look at the logs in GitHub, you don't see, oh, this app accessed your repo. No, they see user X, which is the user that they have credentials for, accessed your repo. So now try to figure out if that's malicious or not. Luckily, there was a telling IP there that was associated with a known attack group. So we could tell that. Keep in mind, they got the notification from GitHub that that vendor was breached in July. So 3 months between the breach and their notification, a month and a half where the attackers already have their code. And you know what's really amazing? They didn't have secrets in their code. Oh, wait, they did, like everybody else. So, of course, they had tons of secrets in code. We could prove that the attackers accessed it. So now you have to look. They had a lot of secrets in their code, not just a little, a lot. Like AWS, GCP, Mongo, a bunch of other things, everything. And so we had to run through all of their systems to try and figure out what was accessed and what wasn't, right? So, of course, all their IP was stolen. We don't know what happened with it since. They never got a ransom demand, so lucky for them. Their AWS was compromised. Luckily for them, their AWS wasn't their main environment. They were a GCP shop. And the reason why AWS got compromised before GCP is just because there's more attacker automation on AWS, because AWS is bigger, right? And they had a lot of problems with customers because of that, because sensitive customer data could have potentially leaked. So not fun, right? And all that because somebody gave permissions to an app on GitHub. So hopefully I didn't scare you too much. What now, right? So I think the first thing is awareness, right? Everything starts with awareness. And I think the awareness that we need to have is that the AppSec market is evolving, and a lot of it is going towards the developer infrastructure. Before, developer infrastructure was always a target, but when it was on-prem, and it was kind of protected by your firewalls and your VPNs and your internal security. Now it's in the cloud. It's so easy. There is no guardrails except for an identity or access token or a cookie. And it just calls the attackers. And now also is this whole code to cloud, CI/CD, it's also much faster. So you need to be aware that your tools are being targeted, and you as developers are being targeted, because it's much easier than targeting your code. And so you need to worry more, unfortunately, which is always a problem with security, about developer security infrastructure. So prevention, right? You need to start thinking on how to secure your environment, putting more controls like we have in any other place. Does it make sense that any developer can authorize any app? I know it's fun, but we don't allow that in other areas in security. Why should we allow that in our code? You should treat this like any other third party. Yes, I know, the tedious questionnaires and the review and the SOC 2, but otherwise, we get that. So prevention, of course, if you don't have MFA on your GitLab or GitHub account, that's the time to do this, but we know MFA is not enough. So a lot of prevention, and then just like anything else, detection. And detection is really, it's an area that's almost non-existent in this space right now, because detection is based on looking at runtime logs, things like that. Again, you can stream your GitHub logs to your SIEM, you can stream them to other places, but you need logic on top of it. And there isn't a lot in there, and you need to start looking at some of the new CI/CD platform, security platforms are doing that. And then the ability to respond. So you need the telemetry, the logs, the artifacts, the things that once something happens, you're able to investigate it and respond, right? Going back to the Cysys breach. if you don't have logs of who is using an access key, you're going to be very blind when that access key gets compromised. So I want to talk in that perspective on one more thing coming from the IBM report. So one of the things I really like about the IBM report, every year they look at what are the things that impact, that influence the impact of a breach. So the impact of a breach is, how many millions of dollars it costs, right? It's roughly around $4.5–5 million, the cost of a data breach. But what they're saying is there are things that if you do will dramatically reduce your cost. So the top 3 for this year is, first one, a good DevSecOps approach. And that is, by the way, super interesting because it was never in the top 3. It wasn't even, it's the top 1 now. It wasn't even top 3. IR plan and testing was always number 1. It's the first year it went to number 2. And the reason is because if you have a good DevSecOps approach, then you can control these things. You are able to detect and respond and recover quickly. Now, if I need to change all my secrets at once, if I have a good secret manager, it's easier. If everything, it's all scattered around my code, it's hard. So, I know this is a DevSecOps track, so I'm preaching to the choir, but this is an area to invest in. Second thing, of course, IR plan and testing. That's been for years the number 1 thing. Prepare for a breach. It's going to help you. Have that mindset. Be able to do that. And then employee training, which we're doing now, right? Or in this context, developer training. And if you want to hear more, now it's self-promotion. I have another talk tomorrow, which is talking about prevention versus response. It's going to touch exactly on the area of IR plan and testing and what you can do to better deal and reduce the impact of breaches. So I'd be happy to see anybody there. So we're getting to our famous apply slide. What do you do tomorrow? Understand your dev exposure. So I think the first thing to take from today is, wait, maybe I haven't thought about this enough. Maybe it's time for me now to go and look, what is my dev exposure? Which developer infrastructure I have, especially in the cloud? How is it connected to my world? Is everything single sign-on? Do I have MFA everywhere? Do I have configuration? Are all developers admin on everything and can do what they want? Or do I have controls, right? And that is a work that you have to do in your organization to make sure that you control that. Because if you don't, it's going to get abused all the time. And then once you map that, next step, improve it, right? And again, put more controls, limit what developers can do. I know it's not fun to limit what developers can do, but even I'm an admin in my company. I'm not an admin most of the time. I limit what I can do because I'm human too. I can do a mistake. I can get attacked by somebody, sending me a phishing email at 11 and in the evening when I'm tired and I accidentally click something. I don't want to be admin all the time. So you have to limit and you have to build controls that allow you to get the permissions that you need when you need them, but not all the time. Get the secrets that you need when you need them, of course, but through a key, secret manager, and work in a way that is secure. And then, start looking into the ability to detection, response, testing. We need to treat our development infrastructure just like any other security system. Do you do red teaming to your GitHub? Probably not. You should. You should ask security. Next time you bring a red team, ask them if they know how to red team our dev infrastructure. Let them go at it. I'm sure they'll find things. But if you don't let them go at it, they'll never find things, and you'll think you're doing great and happy, right? So become proactive, improve your posture. Thank you. And we have some time. I'm happy to take questions.
Hi, is this thing on? Okay. Hi, can you hear me all right?
Yeah.
Okay, great. So my question is about working with DevSecOps, enablement, or platform engineering teams on this, because I'm pretty sure they'll have to be involved in all of this. What time or resource commitment do you think is reasonable when it comes to working with those teams and taking up their time to secure their systems?
So that's a very difficult question to answer without knowing your organization. And you know, it's always a balance because obviously you're going to ask them to, to do things that they don't like. But I think the smart thing about these things is always to create a plan of improvement. You know, you can decide, we're doing a 2 weeks project one time, and then we go from there, allocate a certain amount of sprint in each, a certain amount of resources out of each sprint, and then we build the plan. You're not going to improve everything in one day. And then, of course, looking for the right products that help. There's now, because of these attacks, there are a lot of new products around CI security and key management and making it easier for developers to get access to keys. Again, I'm not too familiar with all the products. It's not my day-to-day, but that's something that can really help.
Thank you.
Any other questions? Okay, then we're done. Thank you.